I have to present you. Last speaker in my subsection, Sher Ali Penza, with a talk on, sorry,
My name
Mehsin
is
Atteya. Mehsin Atteya, I'm sorry, with the talk Homogeneous homoderivations on graded associative rings. Please, up
Thank
to
you
you.
so much. Okay. Thank you so much. First of all, I would like to say thank you so much for the organizers and to me this a great opportunity to meet you. Today, I am so happy to push my presentation, which is under the title Homogeneous Homoderivations on a Graded Associative Ring. Before I start the presentation, maybe somebody ask who am I? My name is Mehsin Jabal Atteya, Department of Mathematics, College of Education, Mustansir University, Iraq. Okay. In this project, we establish interesting result related to homogeneous homoderivation. We prove there the extent of non-trivial family of homoderivations that there are not homogeneous on graded rings. Furthermore, based on the homogeneous homoderivations, we extended certain existing significant roles on the context of prime respect semi-prime rings to the GR prime respect GR semi-prime rings. And the background of this subject over the last 70 years, researchers have been interested in understanding the structure and commutativity of a ring R using specific derivations. Various authors have widely studied this topic, like the references from 3 to 9, specific in 1957, the study of commutativity of prime ring with derivation was initiated. This is the first time to use the derivation here. Since then, the relation between the commutativity of rings and the existence of specific type of derivation has attracted many researchers. The main result of this previous result in this context that a prime ring R with a non-zero centralizing derivation D must be a commutative ring. In fact, graded rings have various applications in geometry and physics and appear in various contexts from elementary to the advanced levels. Based on the rich of heritage of ring theory, many researchers have attempted to extend it and generalize various classical results to graded settings. In references 4, it was shown that if a semi-prime ring R admits a derivation is centralizing on some non-trivial one-side ideal, then R must have a non-trivial central ideal. Moreover, under the similar condition, prime rings are proven to be commutative. As a fact, in 2018, the concept of homogeneous derivation was introduced by Kamenov, let lambda be a G graded ring, and additive mapping kappa from lambda to lambda is called homogeneous derivation if kappa satisfy the two conditions kappa of xy equal kappa x, y plus x kappa of y. Also, kappa of r belong to h of lambda for all r belong to h of lambda. While in the year 2000 came the classical definition concerning homoderivation was delivered via the article 2, where where the additive mapping is homoderivation concerning lambda, like from lambda to lambda. Lambda here is ring, satisfy this condition. This condition now, kappa of xy equal kappa x, kappa of y plus kappa x y plus x kappa y x kappa y, where x and y element in lambda. Obviously here the difference, this is the condition here, same, just add the terms kappa x kappa y, we get the homoderivation. Every homogeneous derivation is a derivation. However, the converse statement is not true, as there exists a derivation that is not homomorphism, homogeneous homoderivation. And this the parameters we choose during my work, lambda represents an associative ring with the center Z of lambda, and G is an abelian group with identity element E for all xy and lambda. We write bracket xy of bracket by this way, xy take away yx, and for an empty subset S of lambda, we write Z sub lambda of S equal x and lambda, such that the bracket x with S equals 0 for the centralizer of S in lambda. A ring lambda is G graded if there is a family of lambda sub G and G capital of an additive subgroups, lambda sub G of here lambda with additive, such that lambda equal direct sum index G belong to G. All the direct sum belong to G lambda sub G, and lambda G times lambda H subset of lambda GH sub GH for every G and H belong to G capital. The additive subgroup lambda sub G is called the homogeneous of lambda. The set H of lambda equal union G belong to G. Lambda G is the set of homogeneous element of lambda. Okay. Here, let eta be a right respect left ideal of graded ring lambda, then eta is said to be a graded right or graded left ideal if eta equal direct sum index G belong G eta G, where G here this definition eta sub G equal eta intersection delta delta G for all G belong to G capital, which is a abelian group, which we mentioned that in the previous slide. That is for X belong eta, we can write X by this way, where X sub G belong to eta for all G and G. A graded ring delta is said to be GR prime or GR semi-prime if A delta B equals 0 implies either A equals 0 or B equals 0. In this case, in case GR prime, in case GR semi-prime, delta A equals 0, then A equals 0, where A, B elements in H of delta. Moreover, a graded ring delta is a GR semi-prime ring if the intersection of all GR prime ideals is 0. Suppose that a ring delta is missed for all AB and eta satisfying the Leibniz rule, i.e. in additive mapping. Here I just repeat the same previous symbol eta, but you can say delta or eta because I speak here about ring. Satisfy Leibniz rule if in additive mapping kappa delivers eta to itself as the following. This is here Leibniz rule, which is called a derivation. The derivation push us in additive mapping kappa sending lambda to itself can be extracted from the last identity where n not equal 0 is an integer. Indeed, the reader, we can say on a ring lambda has n Tauschen free property if for a in lambda when n times a equals 0 yields a equals 0. Let us take closer look at the main definition and it is related example in this section. Now, this is my main definition. Let lambda be a GR graded ring in additive mapping kappa from delta to delta is called homogeneous derivation if kappa satisfy kappa xy equal kappa x kappa y equal kappa of x y plus x kappa y for all xy element in lambda. The second condition, kappa of r belong to h of lambda for all r element in h of lambda, where kappa acts as a homo derivation on lambda and h of lambda represents the set which is equal union g sub g, lambda sub g of homogeneous element of lambda. Next example will, yes. The following example expression on the previous definition represents the main definition. Take lambda equal alpha beta 2 by 2 square, where alpha beta belong to z sub 2, then lambda is z sub 4 graded by lambda naught by this way, and this lambda 1, lambda naught, lambda 2, 0, 0, 0, here 0, 0, alpha, sorry, beta, beta, here alpha, 0, 0, and lambda 3, lambda 1, 0, take the mapping kappa from lambda to lambda as kappa defined by this way, then kappa of lambda naught, lambda 2 equal the 2 by 2 matrices 0 alpha beta 0. This result represents the left side of the previous definition. Now we move to check the right side of the definition of homogeneous homoderivation. Now we after substitute about each one of elements, lambda naught, lambda 2, and use the definition of kappa, we will have this matrices which equal the previous matrices. That's mean homogeneous, that's mean homoderivation. Now we will complete to check homogeneous. Take for t 2 by 2 by this way, and r, the left side of the homogeneous derivation is equal 0, 0. Also the right side now equal after substitute equal 0, 0. Obviously kappa is homogeneous derivation. Now we discuss this important question here, the relation between homogeneous derivation and homoderivation. Every homogeneous homoderivation is homoderivation. However, the converse statement is not true. as the exist homoderivations that are not homogeneous. This can be demonstrated by the following example. This example apply the same technique of the of example one. After here, this lambda equal 2 by 2 matrices elements, and the element is from the real number. And after take lambda 1, lambda naught, lambda 1, lambda 2, lambda 3 by this way, and apply the same scenario in the previous one. We harvested kappa is homogeneous derivation. Now we will seek for the converse. We find is not satisfied because the left side equal 0, 0, while the right side give us to 14, 0, 0, 0, which does not belong to H of lambda. Now now we will find we navigating to auxiliary result is what we will do in the next section. Present lemma 1. Take lambda as a GR semi-prime ring with Z of lambda, then Z lambda contains non-zero nilpotent homogeneous element. Theorem 1, Theorem 1, let lambda be a GR semi-prime ring with a two-Taussian-free property if kappa is homogeneous homoderivation and C belong to H lambda f of lambda such that the bracket C with kappa of x belong to Z of lambda for all x and lambda, then either kappa equal 0, I mean homogeneous homoderivation equals 0, or the element C belong to Z of lambda. Theorem 2, let lambda be a two-Taussian-free GR semi-prime ring with two-Taussian-free property and GR prime ideal eta be a GR prime ideal lambda. Suppose kappa 1 and kappa 2 be homoderivations of lambda. Suppose that at least one of kappa 1 and kappa 2 is homogeneous and their composition is a derivation. Then either kappa 1 belong to eta or kappa 2 belong to eta. In proposition 3.3, let lambda be a GR prime ring and eta a non-zero graded left ideal of lambda. If kappa is a non-zero homogeneous homoderivation of lambda, then it is restriction on lambda is non-zero. Theorem 4, consider lambda as a GR semi-prime ring and eta be a non-zero graded left ideal of lambda if kappa is a homogeneous homoderivation of lambda which satisfies kappa square belong to Z of lambda, then eta is a non-zero central ideal of lambda. The last result here, theorem 3.5, let lambda be a GR semi-prime ring and eta a non-zero graded ideal of lambda. Assume that lambda admits homogeneous homoderivation kappa, which is a non-zero on eta, and satisfy the bracket kappa of x, kappa of y equals 0, this bracket for all xy element in eta, then lambda, which is semi-prime or GR semi-prime ring, contains a non-zero central graded ideal. Finally, I closed my presentation by the list of the papers or some folks to provide any interest to get more information about the subject. Actually, it is not limited, but I take this depended on my work. Thank you so much for all.
Thank you too for your interesting talk.